Good afternoon. It is May 18th, 2013. This is Jason Horak reporting on the Dodge Daytona electric vehicle. Today we are underneath the car again. It's up on the ramps out here on the patio, just so that I could get up underneath it and take a look. And what the focus of today, once again, is temperature sensing for the motor. As you can see on the left-hand side of the shot, there is the little aluminum bracket that I had created last time to mount the temperature sensor to. And so that was right there, which worked out great. You know, it actually was touching the motor at the commutator end, and in theory that should have given me a fairly decent reading. However, this happens to be the most airflow that the car actually gets is underneath the motor right here in this corner. And so there's tons of air that come in across the front. You can kind of see, you know, it's below where like the radiator would be and so forth. So it gets maximum airflow right there, which is all well and good for cooling the motor, not so good for actually getting a good temperature reading. So there is also the air intakes. The grill right there is where the air gets sucked into the motor, and then it comes out down on this end where the fan is. And so consequently, this spot where where I happen to mount the temperature sensor is pretty much the coolest spot on the entire motor, and really doesn't give an accurate reading at all. I drove the car up to Preble, took some readings, and on the highway 80 miles an hour, pulled off, took some temperature measurements, and right at the temperature sensor end, the motor was about 100 degrees. When I measured it up in the middle, roughly here where this hole is, it was 170 degrees. So I said, okay, that isn't a very accurate measurement at all. So I decided to move the sensor. So what I did was, there's another hole just like this one up on top. And so I put a bolt into that hole and a little piece of metal, just a little, I forget what the size is, 1/8 inch I think, just a little piece, just like I had built the sides of the battery boxes with, the supports, and mounted the little temperature sensor in that. So it is now in physical contact with the big iron piece that's in the center of the motor, and it's up on top out of the airflow somewhat. So hopefully that will give me a much better, more accurate, true reading of what the motor temperature is, and that's the plan. Anyway, so the goal here is to take the reading from this particular sensor, which is a voltage that goes roughly between 0 and 12 volts, and convert that into some kind of meaningful number that would hopefully be Celsius or Fahrenheit, so that I can have an idea of how hot the motor is. Since I don't have any way of knowing really what this particular sensor can do, like if I measure it at a certain reading, I don't know what the temperature is at that. I can put the probe on the stove and get kind of an approximation, but I really wanted to just have it in the environment that it was going to be in, and do some comparative analysis. So what I did was I went online, and with the help of one of my YouTube's subscribers, he actually suggested that I check out a Chinese website that sells a lot of like really interesting little devices and so forth. I believe it was called dx.com, and for the Deal Extreme. And I poked around on there, and they had a lot of really interesting devices, and one that really caught my attention was this one, which is a USB, just a little USB device. It's called TEMP ER1, so temp ER1, which is rated, I don't know if you can make it out on the camera, but between negative 40 degrees Celsius and positive 120 degrees Celsius. Since that's roughly the operating range of the motor, it seemed like a good fit. So on the end of this cable is just this little sensor, little temperature probe, that I'm thinking will look very nice, just kind of laying up on top of the motor, perhaps in one of these holes. I don't know, maybe I could kind of strap it in there. Actually, that'd be a good spot right there. And then so I can zip tie it to this cable, and that'll give me a way of looking at it on the laptop as I'm driving down the road. And so with the magic of the USB extension cable plus this little device, my plan is to get this all wired up and into the car so that I can hook it into the laptop and take some readings. So I will go ahead and get that all safely secured here and kind of routed probably up along the side and through the window and so forth, so that'll be fun. But anyway, let me get that all set up and we'll pick this up in a minute. Alright, so we got the temperature sensor all zip tied up in there now, and it should stay there. It may bounce around a little bit, but it's going to stay actually in the motor, and got it wired up there like so, and we'll go up on top and show you how it goes to the laptop. And so there we have our Temper 1 USB device plugged into our USB extension cable, and I have it kind of routed sort of under this thing so it won't get mushed by the hood, and then it kind of goes up here. We'll have to be a little gentle when we close it, and up and through the window and to the laptop. So we're going to go ahead and take a little test drive and take some readings, and I'll show you what the program's all about a little bit later. still spinning at the same RPMs as it was, but it's not passing any current, yet it's going up. That's unusual.
Odd, yeah.
So, but see, that's why we're doing this test, because the temperature's weird, and who knows. Alrighty then. Well, it's now Monday, May 20th, 2013, and as you can see, we've made a few modifications to our temporary setup for the temperature sensing with using the USB device. Basically what we had found during testing, as you saw in the last segment, I had my friend Ray in the front seat operating the laptop, and my brother David was in the back seat running the camera. As we kind of drove around all over the place, just trying to take a bunch of temperature readings and log them in the little program that I wrote for the Soliton data logger. And basically what we ran into was that the little USB device, the Temper 1 device, kept dropping out. It would just disappear out of Windows, and then it would come back, and then it would go away and come back, and it seemed kind of random. I mean, we couldn't really figure out, you know, it didn't seem to be related to how fast we were going or how much acceleration was happening. I could not figure out why this thing kept dropping out. Later, upon reviewing the video, I thought about it, and I had mounted the thing right here in this hole, and then it kind of went up and wrapped around this, and then went up into the up into space there. And I got to thinking about where the electromagnetic interference was being generated in this motor. It comes out in waves from the motor. These cables are twisted together, you know, very deliberately in order to eliminate the EMI, because you basically have the one, you know, negative and the positive wrapped around each other, so that the field from one cancels out the field from the other, and you don't get a lot of interference. Well, this cable here that goes between the two different parts of the motor is just a straight through, which means that there's going to be a huge amount of electromagnetic field that's released around this cable, and that incidentally was going right next to where I had the temperature sensor running. So anyway, what I've done is moved the cable, moved the temperature probe up here so it's laying right on where my coolant temperature sensor is sitting, so it's about as accurate as it's going to possibly get. It's touching the motor, it's touching that, it's right there, up in the airflow location that's the same, etc. And just have it zip tied there so that it'll stay and won't move too far when we're trundling down the road. But I also took a page from my science fiction nerd history, and I decided to use the closest thing at hand to shield the cable, which is tinfoil. So I've wrapped the entire little dinky wire coming out of this thing that goes to the USB device in tinfoil. I don't know if that actually makes any difference or not, but it seemed like a good idea. And I routed it as far away from this cable as I could get. There's, you know, a little bit of clearance there, you know, basically as much as I can. And there we go. So what we're going to do is try to do one of these camera moves without making everybody ill. Is to go up, and as you can see, it comes up there like so, and I just kind of have it in between the motor and the battery box. So this is the plate that holds the motor up, rather, and under there. And so now the USB device is here. It's covered in electrical tape to keep it held together with a USB cable as we trundle down the road. Up under here where it has some clearance where the wiper is, and then on into the laptop. So I'm going to go ahead and get the car down off the ramps, and then we'll do a little bit of a run through on what the software looks like and take a little test drive. Be right back. Okay, we have the car down off the ramps now, and I'm just going to take a quick look at the program that I wrote. to show you what that's all about and kind of explain how we've been doing this data collection process. So here we go. And as you can see, it shows that the soliton is disconnected currently. If we go ahead and turn on the soliton, it comes up and you see pre-charge, engaging contactors, and then running. So it queries it fairly frequently and gets all that data as it comes up. And now you can kind of tell in the top field we've got how long it's been running in hours, minutes, and seconds, the pack voltage, the pack amperage, the motor voltage, the motor amperage, the motor RPM, the motor temp, and then the inputs. The rest of this stuff is not really all that important as far as for what we're doing today, but most specifically we're concerned with the input 1 voltage, which is coming from that little sensor, and the motor temp doesn't actually exist. It doesn't come from the soliton. We're going to try to calculate that using some other means. At the moment, what we're doing is we've got this temper USB sensor section, and that sensor is kind of weird. Basically the way that it works is that it kind of takes over the keyboard functions, and if you hold down the numlock key, it's going to turn it on and start basically typing data. And so we're going to hold down the numlock key until it turns on, and there we go. So what it's showing here, I'm not sure if the camera's making this out at all, it's kind of a black text on a white screen, but it's 27.19 is what the sensor is reading and sending to us. The motor temp is just taking that field and dumping it over here into our soliton data, which then can be logged via the start logging button showing here. So that creates a little file that's named based on the current date and time and second that the logger file was created, and it's just putting all this data into a file. So anyway, that's basically the process, and we'll go out for a little bit of a drive and see what we come up with. What was happening with the drive earlier was that it kept dropping out all the time. Basically, you'd see this would not be flickering because there would be nothing typing from the USB device. So hopefully with my aluminum foil shielding method, that will make some kind of a difference, and maybe I'll actually get some driving log data that doesn't keep dropping out all the time. Anyway, I'm going to go for a little bit of a drive, and we'll see what we come up with. Be right back. Well, that, as they say, was not entirely successful. Basically what happened was by the time I got to the end of the driveway, the temper USB device had already kicked out, and had to unplug it, plug it back in, restart it while driving. So I basically went to an Applebee's that was about 2 miles away, give or take, and on the way there and back I probably had to reset the USB device a dozen times. So clearly the aluminum foil shielding method did not work as planned. But that's okay, it's how we learn. As an added benefit, I managed to, I think, break the USB device. It still detects in Windows and comes up and stuff, but when we hit the numlock key and it starts recording, it comes back. Again, I'm sure the camera isn't making this out, but basically it says 0.0 degrees Celsius, and that's all it ever gets anymore. So the device itself is working, but this little temperature probe seems to be kicked. However, during the go ahead and shut that off, because otherwise it'll freak out my world. Okay. So this is the little program I wrote, and we did the log. And so what I did was took that information from the logger and plotted it in some Excel graphs. And basically what we're seeing here is that there is some variance. It does bounce around a bit. That can be attributed to noise, or possibly from just inaccuracies in the test equipment. So what this chart shows is the voltage that the Soliton was displaying on that input pin on the bottom, and then the motor temp in Celsius based on the temper USB device. So basically what we're seeing here is a very linear progression, other than jumping around a lot. So at 1.123 was our lowest measurement in this case, and we measured 20 degrees Celsius. Our highest point was 4.553 volts, and that was at about 62 degrees Celsius. So anyway, it was doing pretty good. So then that was the original, this graph that we're seeing here is actually the original one that I made when Ray was riding in the car taking readings, and I went through and massaged the data quite a bit to remove all the zeros and the obscenely high values that it came up with, just basically every time that the temper device had crashed. So anyway, this gives us our low and our high point, which is really what I was looking for, as well as a general trend over the course of a large temperature change as far as how much we were getting in the voltage. So this second graph, this one I did with that little drive up to Applebee's with the aluminum foil method. And you can see it kind of bounces around a lot, and then it kind of stabilizes right about here. This is when I got back from Applebee's and I just let the car set, and then the temperature continued to rise, and then it started to fall off. Again, that's very consistent with what I've seen from this motor. As far as when you're driving, it really doesn't get hot at all. I mean, it's the rotor is spinning, thus the fan is spinning, and it's keeping the motor nice and cool. It's when you come to a stop and it's just sitting there that the temperature from the commutator kind of radiates out to the case of the motor. So nice and cool, of course, is relative. It's nice and cool in the outside case temperature. I'm sure, you know, obviously it's much hotter on the commutator and on the rotor itself. But anyway, so really what I need is a better temperature measurement, more like an infrared or something that's pointed directly at the commutator and where the brushes make contact. But anyway, just wanted to show you kind of what I'd come up with from collecting all that data. And you know, the data itself is pretty straightforward. It's just the same kind of thing as you're getting out of the original Soliton program, but I broke it down a little bit more in that it's pack voltage, pack amperage, motor voltage, motor amps, so it does all the calculations for those things for you before it puts it in the log file. And then motor RPM and motor temperature, again, that's coming from, currently in this version, it's coming from the temper USB device. Whatever's typed into that field is what shows up here. Input 1, 2, 3, auxiliary voltage, temperature of the controller, throttle, and so on and so forth. So basically the log file, I tried to keep it as similar to the original Soliton log file as possible. It does log the statuses. I don't know if the camera will make it out, but over here we had some kind of weird statuses where we got an 1157 and a 133. Those were outside of the range handled by the original program, and so I just logged them as unknown status and the number. So at some point, if we find out what those are, we can go from there. But anyway, so long story short, lots of data was collected, and there we go. Okay, so in an effort to kind of show you some of the features of my little Soliton EV display and data logger program, I set up the camera on a tripod, still pointed at the computer screen, but without me holding it, so I won't be flailing around quite so much and looking like I'm having a fit. So anyway, without further ado, this is the little program, and you've kind of seen it before in the earlier videos. But I wanted to show you where we're at right now with it, and how much further we've come along. So basically, it just is a graphical display of the data stream, the UDP data stream coming from the Soliton. And it's the same functionality as the little logger application that originally came with the Soliton software. And it's just a little prettier and does some extra features that I wanted it to do. Namely, calculating some of these values and showing them on the screen in real time. So, in specific, the pack amperage and the motor voltage are two values that normally don't come across that data stream, and they weren't being displayed on the screen before. So now you can see them as you're driving. It's kind of useful to me because I can compare the pack amperage with what my JLD 404 meter shows and can tell that we're actually logging that information accurately. Whereas before I had some issues with my formulas, and in previous charts and graphs that I made, the data wasn't really accurate for the pack amperage and the motor voltage. But now I've got it all worked out and it's correct. And obviously the other main feature of this program is the motor temp, which does not come from the Soliton at all. It's actually being calculated based on the input 1 voltage, or input 2 voltage, or input 3 voltage, depending on what you've decided to use. So anyway, so what I've been working on for making this program a little bit more fancy is I've added this extra panel over here and a refresh button at the bottom. What this does is it actually queries the Soliton to get its information from the web page. So again, just to review, this is the Avnetics Soliton settings website or web page that comes up, and what I'm concerned with myself is this section right here, which is the minimum battery voltage at no current, minimum battery voltage at full current, maximum battery current, and so forth. Those are the values that really affect the performance of the car and how responsive the pedal is and all that kind of stuff. This section up here is useful if you're doing idle, and also if you have like the motor speed sensor, RPM sensor, and that kind of thing, and good for tweaking, but not necessarily something you're going to want to mess with when you're out on the road, typically. Anyway, so basically what how I've got this program written is it has 3 buttons at the top that you can press to set some preset values on the Soliton. So like just as an example, right now we're at max pack current of 500 amps and some other daily driver type settings. So if I hit the battery saver button, the first one, it goes through, sets it on the Soliton, and then refreshes what information the Soliton is now set to. So our max battery current is now 360 amps for battery saver, and some other more conservative settings, including a glacially slow slew rate of 500 millisecond slew rate. So anyway, so with a quick press of a button we can change these settings. We can go from battery saver mode to drag race mode, and it just programs the Soliton with those kind of preset settings, and there you go. So I just figured this would be useful. It's kind of similar to what the Nissan Leaf and the Toyota Prius and things have for setting the different performance levels. I think you can, I don't actually have one of those cars, but I think you can pull up their little screen and say, okay, I want to burn more gas or whatever, and go faster, and get more acceleration. But now us Soliton users can do pretty much the same thing by running this little program and pressing the button. So anyway, that's kind of the user interface for the application. The way that it works for configuring is I have a configuration button here that brings up this screen, and most of it, on the left hand side anyway here, is for the motor temp. So basically programming in the motor temp input, like which one we're going to be using, as well as the low value or the high value of the voltage, the high value of the Celsius measurement, low voltage, and low Celsius. So all that is like on that graph that we saw earlier, where it was a very linear progression. You basically would take your measuring device and measure the temperature at cold motor temp. Like say, what I'm going to do is put an ice pack on the motor sensor and right on the motor itself, and then measure that temperature for my low, and then whatever the voltage is that the soliton sees at that low. And then I'll do the same thing by taking the car, running it out on the highway for a bit, parking it, letting the motor heat up nice and solidly, and then taking another measurement of whatever the temperature is at whatever voltage it happens to be. Because we're just assuming a nice linear progression, which is more or less accurate. I mean, it's not 100%, but it's close enough for government work, as they say. And so that'll kind of give us a good approximation of what the motor temp is. Again, with my sensor, this is an outside case temp, or motor case temperature, not really the commutator temperature or anything. But if we had a better sensor that was pointing at a different spot, but was still giving us a voltage on the soliton, we could use that and it would just work. Anyway, for the different configuration buttons up here at the top, I have different tabs. Battery saver, daily driver, and drag race in this case. Note that the name is completely arbitrary. You can put in whatever you want. We could call this Econo mode or whatever, and it just changes the setting of the Econo mode, and now the button says Econo mode. So it doesn't have to be my lame button names. It can be whatever you want. But anyway, so basically, these are just those settings. Minimum pack voltage at no current, minimum pack voltage at full current, max pack current, and etc. So you can go through and customize these any way you want, and then you'll have 3 buttons available to do different modes on the fly without having to go into the Soliton interface and submit it on the web page, risk crashing the web server, which happens if you refresh too quickly, and all that kind of stuff within a web browser. So this is kind of set up to try to be as resilient as possible, try to not break the Soliton web browser as much as possible, and to give you those settings just on the fly. So and of course, the program still supports the logging of the data from this side, just like it always has. And it creates that little text file that is named and numbered, it's named based on the exact date, time, and second that the button was pushed. And that way, the log files won't overwrite each other as they go. So just to show you real quick what that looks like, so this is one of the files that it just created this. You know, just a bunch of columns, very, very similar to the original Soliton data logger file, except that I've added in the pack amperage and the motor voltage and then the motor temp, because those are now being calculated by my program. So other than that, it's pretty straightforward, and it does update every 100, I believe that's 100 milliseconds is the frequency at which it updates the file, and this is more or less consistent as far as the time goes, but it does vary a little bit. Sometimes if the Soliton is busy, or it hiccups because you're sending data settings over, you might get a little bit of a pause in the file. It'll still keep on chugging, and even if you turn off the Soliton and turn it back on, this log file will just keep on logging, and it'll pick right up where it left off. So it's kind of cool. As far as the configuration, let me just show you real quick that this is the little config file that it creates. Again, straight text, nothing too complicated, just all these different settings. There's our Econo mode that we typed in. it's about as simple as it gets. It's a tab delimited file, so it's got some headers and tabs. And so you could technically edit this text file yourself in Notepad if you wanted, but obviously it'd be easier to do right within the program. So anyway, that's it for today. I just kind of wanted to give you a run through of what my cool little program does, and again, I'll be expanding it in the future, kind of on an as-needed basis. I would like to come up with a mode that it can operate in where it has pretty gauges and stuff instead of the just the straight text. I have all the data now, so literally it's a matter of creating controls that look pretty and throwing them on the form. So it's not a huge deal, but my graphic artist skills are a little bit weak, so that might take me a little bit of time. But anyway, so that is the program. As of June, what the heck is today? It's actually June 16th now. And there we go. So if anybody would like this program, I would be happy to send you a copy. It's just one little executable file, and then the config file is, again, a text file that you can customize as much as you want. And yeah, so I'm not really sure how to get it to you other than putting it in a zip file and emailing it. I can't post it up on the blog, but maybe I can find some spot on the internet that'll let me post a file that I can share with people. Anyway, if anyone's interested, let me know. And otherwise, have a wonderful day.